Okay, so welcome to this first video in the playlist on thermodynamics. In this video, what we're going to discuss is entropy and the second law of thermodynamics. Okay, so what we're going to start off with then is motivation for the concept of entropy. And fundamentally, the motivation for this concept comes from asking a very, very basic question, which is, why do chemical reactions occur? Okay, and to try and get a feel for this question, let's have a look at some examples of chemical reactions that occur. We will then come up with a very basic theory, okay, and we'll see how that theory is wrong, and we will then see how we can improve this theory, how we can get a better theory, okay, and that's the theory of entropy, basically. So we're going to start off basically with the theory of energy, and then we're going to see how energy isn't enough basically to understand how chemical reactions occur, and we have to go beyond that, we have to go to entropy. Okay, so let's start off with a basic reaction that occurs. So we're going to do the reaction of ammonia gas with hydrogen chloride. So basically, if you mix ammonia, which is a gas, okay, at room temperature, so ammonia has this structure, it's nitrogen bound to 3 hydrogens, okay, like so, 1, 2, and I'll put another one here, and then it has a lone pair of electrons. Now, at room temperature, ammonia is a gas, and at normal pressure we're talking about. Okay, so we take ammonia, which is this gas, and we mix it with another gas, which is hydrogen chloride. Okay, so hydrogen covalently bound to a chloride, to a chlorine atom. Okay, so this is hydrogen chloride. And again, this is a gas. Okay, so let's put both of their names. So this is ammonia. Okay, and we're mixing it with another gas, which is hydrogen chloride. Okay, so what happens when you mix these two together? Well, they react fantastically with one another, okay? And the reaction goes pretty much to completion. You make a whole bunch of ammonium chloride, okay, written like so, NH4Cl. And this is an ionic compound where basically what happens is, in this covalent bond here between the hydrogen and the chlorine atom, you have 2 electrons, okay? One from the hydrogen and one from the chlorine. I'll put these here with dots and crosses. Okay, and what's going to happen is that hydrogen nucleus is going to break off and it's going to leave its electron with the chlorine atom. Okay, so hydrogen's nucleus is usually just a proton. There are different isotopes of hydrogen, but the most common isotope of hydrogen has no neutrons and just has a single proton. And what's going to happen is this proton is going to go and associate with this centre of negative charge, which is the lone pair of electrons on the nitrogen of the ammonia molecule. Okay, and what's going to happen is it's going to form a covalent bond effectively with this nitrogen atom, like so. And obviously the understanding of a covalent bond is that one electron comes from each of the 2 members. So if nitrogen provides both electrons, effectively what it's done is it has donated away one of its electrons to the hydrogen nucleus. Okay, so effectively what it's done is it's given one to the hydrogen nucleus, and then the hydrogen and the nitrogen have then said, okay, let's share electrons. So the hydrogen shares the electron that it's just been given by the nitrogen with the electron from the nitrogen, and they form a covalent bond. So effectively the positive charge gets transferred onto the nitrogen atom that's at the centre. Okay, so this is the ammonium cation. And now we also have the chloride anion here, which is the chlorine atom with the extra electron that it kept from the hydrogen, and that's negatively charged. So this is ammonium chloride. Now, ammonium chloride is actually a white solid, so when you actually do this reaction, when you mix ammonia gas with hydrogen chloride gas, you get these clouds of white ammonium chloride being formed in front of you. Okay, and the reaction goes to completion. Okay, so if you put an equal number of ammonia molecules with hydrogen chloride molecules, so you put exactly the same amount into some tub, Okay, so let's imagine some glass container. Okay, and we're going to put the ammonia molecules and the hydrogen chloride molecules into this glass container. Okay, and if you put exactly the right numbers of both of them, so if you put the same number of ammonia molecules and hydrogen chloride molecules, then all of them, in principle at least, if you gave it enough time, would be converted to ammonium chloride. Okay, so it goes, or at least, you know, it would be negligible how many wouldn't convert to ammonium chloride. Okay, so it goes to completion. Okay, so it's a one-way reaction. Now, let me show you another example of another chemical reaction which goes to completion. Okay, so this example is the combustion of magnesium, the metal magnesium, and you must have seen this at some point. So basically you take a magnesium strip and you set fire to it, and obviously the thing that happens is you get this really intense white light being emitted from the magnesium strip that is on fire. And what is happening is the magnesium atoms within the metal strip are reacting with oxygen molecules, and really what will happen is two magnesium atoms will react with an oxygen molecule. So the magnesium is a solid, the oxygen molecule is a gas. Okay, so this is just oxygen double bound to oxygen, and what you create basically is magnesium oxide. Okay, so you bind the magnesium ion to the oxygen atom, and it's via a ionic bond